Hi guys, it's Tom with Heritage with a very shaky hand because I've had 2 coffees this morning, a bit tired. Today we're doing something a little bit different with Heatmiser, so let me explain what we're going to do.
So what you're looking at here is the control system, heating system, filtration system for one of our customers' swimming pools. Now we actually came to look at the heating inside the house. Customer wanted central app-based control to be able to monitor and set their heating controls. So we've done all that side of things. But while we're here, we noticed that this pool system is on all the time, always calling for heat. You can hear all the filtration and everything is always on. Now the pool obviously is a private pool, it's not used all the time, so the customer wants to be able to schedule from the phone when all these systems come on, when they're going to use the pool, and then obviously turning that off is going to save them loads of energy. So initially we looked at I think this is like a second-hand reconditioned unit. The controls up here do not provide enough granular control, and in fact I don't really think they're working as they should do. So this is just on constantly, one temperature. Technically you should be able to set 2 different heating levels, one for when the pool's in use and one for when it's not, but that's just not working. So if we look over to this panel board, you can see we've got all these different systems: filtration pump, various boosters, various pumps, and then various MCBs in here, one of which is the Calorex system, which does all the heating. We've got a rotary isolator here which isolates this whole panel, and so what I'm going to do is I'm going to put a DIN rail mounted contactor in here. So we'll take the cable from the rotary isolator into the contactor, and then out of the top of the contactor will go into the bottom of the main isolator here. On the outside I'm going to mount a surface box, and we're going to use a Heatmiser NeoStat E, which I've got on somewhere. NeoStat E. Now, ordinarily you would use these for electric underfloor heating. They're capable of switching loads, I think, of up to 16 amps. You can also just use them as a dumb time clock, so there's no temperature sensor in use, as it were. You're just using it to set schedules. So that's what we're going to do. And so we'll give this a supply, and then the switched output will control the contactor coil feed. Obviously when this is set to on, contactor will be pulled in, the pool will be on, because obviously we'll give it juice via this rotary isolator. When the time clock's set to off, all of this gear will be off. We've checked this out with the pool guy that the customer's got. He's more than happy for us to be able to switch everything like that. Yeah, so the upshot is big savings on electricity bills, as you might imagine. So let's get on with this. So here's our contactor. It's 4-pole, normally open, which means without any voltage applied to the coil feed, all of these contacts are open. As soon as the coil feed is activated, contactor closes these connections, so 1 is linked to 2, 3 to 4, 5 to 6, 7 to 8. So for my little Heatmiser module, which is going to be mounted here, I'll pinch a feed from the top of here to supply the unit. We'll have the switch line out going to A1, and then A2 will just pinch a neutral from somewhere. So when the time clock's activated, some voltage down A1, neutral return on A2, pull the contactor in, and that will allow us to control all of this gear remotely. Right, so what I need to do is pinch a supply from one of the phases and a neutral to feed through to the Heatmiser unit. Now, because of the size of the terminals on this, I think it takes a maximum of a 2.5 millimeter cable. And what I've needed to do is just work out the fault current here, which is about 500 amps, maybe a bit more. Pool's protected by a C32 breaker. So 500 amps will trip that within 0.1 seconds. So we'll then plug that into the adiabatic equation, rearrange it to find the cross-sectional area needed to carry the fault current for 0.1 seconds. That gives me the cross-sectional area, which is less than 2.5 millimeters squared. So in other words, because this is a fixed load, we don't need to give it overload protection, but we just need to make sure that the cable is protected in the event of, you know, a fault, as opposed to an overload, which in this instance it is. So I'm happy to take 2.5 mil into this unit without needing to fuse it down. Okay, so we've attached the box. We just use a stuffing gland as a way of protecting the cables on entry to the back box through the metal enclosure. You can see we've pinched a supply and a neutral for the incoming side, from the incoming side of the contactor. Obviously if we pinch it after that, then as soon as the contactor clicks out and opens these contacts, then this would lose power. So we've got to tap it off before all of the bits that we want to control. And then we've got away go neutrals, taking a neutral out to the unit. So we've got permanent supply in, and we've got switch slide out. And then see, that just goes around there into the coil feed, and then neutral going back to our little neutral joint box in the back there. Right, let's get all this back on and test it. The only other thing that we've found is the L3, the grey phase, for some reason isn't connected up. The screw terminal's loose, and yet you can see here we've got 3-phase breakers, cables coming out. So just need to see, whoever's done this panel board has done it very neatly. We've got everything labelled up, so I need to get the drawings out, follow that, see where it goes, see if that equipment's you know, actually being used and in service. If not, then we maybe don't need to reconnect that grey phase, but yeah, so we need to have a look at that. Alright, so we've just juiced the circuit up. Now it reads an error message because when you boot it up for the first time, the NeoStat E, it's functioning as a thermostat, and because it's for underfloor heating, it needs a floor probe installed, which obviously I've not put in because we're not using it for that. So you just hold the setup button for a few seconds, and then you hold this for 10 seconds. And this sort of factory resets it and allows you to then select time clock mode. So I think we've got the option of 1 or 2. I can never remember which is which, so just going to double check in the instructions. Once you've picked the right setup, so one of them is for time clock, one of them is to have it function as a thermostat, you just click the tick. Let's have a look at that. Right, so it's actually number 2 for time clock mode. So now it's juiced up. I've paired it with the NeoHub that we've already got on the system. You see we've got all these different zones. There's one that's offline for some reason. But you can see how many different products this house had. I think 6 manifolds, 6 underfloor heating manifolds. There's tile radiators, there's electric underfloor heating, and now there are pool controls. So this is the sort of profile that we've just set up. So at the moment the pool controls are on. They come on at 7 in the morning, they go off at just before midnight. So yeah, they're going to be saving quite a lot of energy there, because previously it was just running 24/7. So that's just a quick example of how you can use Heatmiser Neo E essentially as 16 amp switches. So yeah, if you like this video, don't forget to hit like and subscribe, and if we can help you out with any Heatmiser installations, then don't hesitate to get in touch.